identify common ports and connectors. Devices connect to a computer using ports and connectors. A port is a hole or a slot that receives a connector and allows a device to physically connect to a computer. A connector is the distinctive plug at the end of a cable, jack, or electronic card that can be physically plugged into a port. Each port has a unique function and accepts only the connector designed specifically to fit into it. Common examples of physical ports and connector pairs include the USB port, HDMI port, DisplayPort, and speaker port. An interface is the point of communication between two or more entities. An interface can be either hardware or software-based. Examples of hardware-based interfaces include the point where a port or card connects to the computer motherboard, the point where a peripheral device connects to the computer, or a touchscreen device that records human inputs. Software interfaces provide routes for communication between software applications, the operating system, and hardware. For example, drivers are software interfaces that enable communication between the operating system and the computer's hardware components. Let's take a deeper look and learn to identify commonly used interfaces and connectors. The Universal Serial Bus, or USB, was built by a consortium of 7 companies to replace the many varieties of connectors available in the market with a common, simple-to-use, and fast standard that could be used across devices and peripherals. Since its launch in 1996, the USB connector has gone through several iterations. When USB was first launched, it supported speeds of 1.5 to 12 megabits per second. It also supported 4 different connector types: Type A, Type B, Mini A, and Mini B. USB 2 was launched in 2001 to increase data transfer speeds up to 480 megabits per second. It also added support for the Mini AB connector and introduced the Micro A, Micro B, and Micro AB connectors. The USB 3 series of updates saw speeds increase to 5 gigabits per second, with USB 3.0 in 2008. The Type-C connector was launched with USB 3.1 in 2014 with speeds of 10 gigabits per second. It was made backward compatible with all versions of USB up to USB 2. USB 3.2 was released in 2017 with speeds of 20 gigabits per second. The mini connector types were discontinued in this version. USB 4, based on the Thunderbolt 3 and 4 protocol specifications, was released in 2019 and continues to be the latest and greatest version for USB devices. It supports speeds up to 40 gigabits per second over a Type-C connector. The Type A USB port has an elongated rectangle shape with 4 pins and carries both data and power. It is typically used for keyboards and mice. The Type B port is almost square with beveled outside top corners. These also have 4 pins and are mostly used with printers, scanners, and similar devices. Mini USB ports were introduced for use with smaller devices such as digital cameras, mobile phones, and tablets. They have 9 pins and are smaller than Type A or B and twice as thick as micro USB ports. Micro USB ports are similar width as mini USB, but much thinner with only 5 pins. These were designed to replace mini ports on smaller devices. And finally, the 24-pin Type-C with a reversible connector is designed to be future-proof and to replace various Type A and B connectors. Thunderbolt is a commonly used hardware interface developed by Intel and Apple. It was originally marketed under the name Lightpeak, but was later renamed to Thunderbolt. The Thunderbolt interface is very versatile, combining data transfer, display, and power into one cable. It allows up to 6 peripheral devices to be connected through a daisy chain. Thunderbolt interfaces have 4 versions. Versions 1 and 2 use the same connectors as a mini DisplayPort or MDP. Versions 3 and 4 reuse the USB-C connector. While Thunderbolt 3 doubled the data transfer rate to 40 gigabits per second, Thunderbolt 4 has support for USB 4 protocol and data rates, and dual 4K displays. It also supports Thunderbolt Alternate Hubs USB, and not just daisy chaining. All Thunderbolt ports are identified using the Thunderbolt symbol to differentiate them from regular MDP and USB-C ports. Before Thunderbolt, FireWire was a popular interface on Macintosh computers and is comparable to the modern USB interface. It comes in various shapes. The 400 is a slimmer connection with one rounded side, and the faster 800 connector looks like a thicker version of the USB. FireWire ports use a serial bus architecture to transfer information one bit at a time. This makes them lighter and cheaper than parallel buses that use a number of different physical connections. FireWire interfaces have been replaced with Thunderbolt and USB interfaces on modern computers. However, users with older computers, as well as the automobile and aerospace industries, still use these ports. PS2 ports were developed by IBM for their IBM Personal System 2 series of computers and are named after them. They are round and have 6 pins for connectivity. These ports were specifically designed to connect the keyboard and mouse to the computer. Although the two PS2 ports look identical, they are not interchangeable and they are identified by different colors and symbols. And although the PS2 port is considered a legacy port, modern PCs may still carry them as they are preferred by gaming enthusiasts, legacy users, and industrial applications. eSATA is the most popular port to connect external storage devices, such as external hard drives, to computers. eSATA allows hot swapping, which is the replacement or addition of external devices without stopping, shutting down, or rebooting the host system. Since 2008, eSATA has been upgraded to the eSATA P interface that allows for both eSATA and USB devices to be connected through the same port. eSATA has been through 3 main revisions, and data transfer speeds have doubled with each revision. In this video, you learned that a port is a hole or slot that receives a connector and allows a device to connect to a computer. A connector is a plug at the end of a cable, jack, or electronic card that can be physically plugged into a port. An interface is a hardware or software-based point of connection between 2 or more entities that enables communication. Software ready for use. Different systems require different types of installations. While certain installations are straightforward and can be performed by non-professionals, others are more complex and may require the involvement of specialists. The types of installation can be broken down into 2 categories: plug-and-play and driver installation. Plug-and-play, sometimes abbreviated as PNP, describes devices that work with a computer system as soon as they are connected. The user does not have to manually install drivers for this device, or even tell the computer that a new device has been added. Examples of PNP devices include mice and keyboards. If a PNP device doesn't function in Windows, the user should look in Device Manager for an indication of a problem with the device. Device Manager is part of the Windows operating system. It allows users to view and control the hardware attached to the computer. When a piece of hardware is not working, that hardware is highlighted with a yellow icon for the user to deal with. One cause of device malfunction is an outdated driver. A driver is the software that allows a device to talk to the operating system. Updating the driver may restore proper function to a device. To update a device driver in Windows 10, follow these steps. First, open Device Manager by typing Device Manager in the search box and selecting Device Manager. A list of names of installed devices will display. Click the arrow to the left of the device you're looking for to expand the list. Right-click the device you'd like to update and select Update Driver. An IP-based peripheral is hardware that is connected to a transmission control protocol, Internet Protocol, or TCP/IP network. Examples of IP-based peripherals are wireless access points, wireless routers, IP security cameras, network print servers, and networked printers or multifunction devices. These devices must be connected to a local area network or LAN or the Internet for installation and functionality. When you install a device, you get it ready for use. But when you configure a device, you're setting it up to work according to your preferences. Web-based configuration is used for networking devices, such as routers. This makes the setup process easier. All your work is done on a web page, which is generally found on the manufacturer's website. In this video, you learned that hardware and software installation is a prerequisite for functionality. One of the advantages of plug-and-play over driver installation is the speed with which a device port on your computer. Serial port cables usually have 9 pins, parallel ports have 25 pins. Attach the cable connection to the computer's port. These cables include side screws that attach to the computer body so that the cable remains connected to the computer. Power on your printer and configure the printer. Printer connections are available within the Settings app. Using the Settings app, select Devices, Printers, and Scanners, and then select the plus Add a Printer or Scanner option. Windows often automatically detects connected printers. If the printer's software is installed, select Open Printer app to configure the printer. If you don't see the printer that you want to add, select the link for the printer that I want isn't listed. This option is beneficial for older style printers and network-connected printers. Follow the prompts to find a printer using other options, including older printers, network printers, Bluetooth printers, or any printer needing a manual connection. In this video, you learned that printers require software known as drivers for the computer and the printer to be able to communicate with each other. In some instances, to use all the printer's capabilities, you need to install the manufacturer and contrast wired and wireless connections. Today, hardly any device operates in isolation, unless that's what you want. Communication technology allows components to communicate over a network by converting information into data packets that are sent from one smart object to another in dialogue. Like papers in an envelope, each data packet contains information about the sending and receiving device, along with the message that needs to be transmitted. This ensures that only the designated device receives the information. As such, devices built to talk over a network can communicate with each other. A finite number of devices can be connected in a closed network or to an unlimited number of devices over an open network, such as the Internet. For example, your phone could be used to control your humidifier on your home network. Either type of network connection can be wired or wireless, such as Bluetooth. An RJ, or registered jack connector, is used for landline telephones. There are 2 types of RJ connectors. An RJ11 is used to plug a phone into a wall outlet and for connecting a handset to a telephone. RJ45 connectors are used for connecting computers and other Internet-enabled devices, such as wired credit card readers, servers, modems, gaming consoles, and smart TVs, to Ethernet-based local area networks or ELANs. The RJ45, like the RJ11, has a plastic tab to prevent misconnections between the connector and the port. Wired connections allow faster data transmission. This connection offers speeds up to 5 gigabits per second, while wireless connections have a speed of only 1 gigabit per second. They're more reliable than wireless connections because they have consistent speed and connectivity. Wired connections are not impacted by weather conditions and are immune to signal drops and dead zones. Wired connections are less prone to radio interference, so there are fewer dropped packets that need to be retransmitted. This translates into greater network stability and speed. As devices need to be physically connected in a wired connection, they are more secure and less likely to be hacked. Wireless connections use different technologies based on connection requirements. For example, wireless fidelity, or Wi-Fi, is used to connect computers, phones, tablets, smart TVs, and other devices to the Internet. It works by connecting a wireless router directly to an Internet modem. The router acts as a hub for all wireless-enabled devices within a range to connect to a home network and the Internet. Note that newer modems have built-in routers to avoid the need for connecting a separate device. Bluetooth technology, available since 1998, uses ultra-high-frequency radio waves to connect devices in a one-on-one connection over short distances. The connection between a sending and receiving device is established through a process called pairing, where both devices send a passkey to recognize each other. Radio frequency identification, or RFID, is used to identify and track objects using tags. RFID devices can operate over several hundred meters. RFID is used in the automatic collection of road tolls through tags affixed to vehicle windshields. Other uses of RFID tags can include implanting them in pets and livestock to enable easy identification, tracking pharmaceuticals through warehouses, preventing theft, and expediting checkout in stores. NFC, or near-field communication, is an evolution of RFID technology that works over extremely short distances. Near-field communication transmits data through electromagnetic radio fields to enable two devices to communicate with each other. To work, both devices must contain NFC chips. The short range makes NFC power efficient and increases security by eliminating accidental triggers. Common implementations of NFC include key cards for hotels and office access, digital wallets, and chip-enabled credit cards. Wireless networks are becoming increasingly commonplace because of their advantages over wired connections. For example, there's the increased mobility. You will be able to describe how graphic devices operate on a computer, list characteristics of the display system, and recognize the different types of display connectors and their use. Computers communicate with a display unit, such as a computer monitor, using display cards called the Graphics Processing Unit, or GPU. Generic graphic cards are built into a computer's motherboard and are good for everyday computing requirements. Graphic-heavy tasks, such as multimedia editing and 3D gaming, require specialized high-end graphic adapters. Radeon chipsets by AMD, GeForce and Enforce chipsets from NVIDIA, and other adapters from SIS, Intel, and VIA are popular products on the market. When selecting a computer display, the resolution, refresh rate, and bit or color depth all play an important part. The resolution is the number of horizontal and vertical pixels, which determines the clarity of an image or text. The refresh rate, based on how fast the screen refreshes to show a new image, governs the video playback quality, while the bit depth, which describes the total number of supported colors, dictates how close the colors are to real life. Higher resolutions, refresh rate, and bit depth result in higher quality images, smoother video playback, and true color displays. The display quality is directly linked to the amount of processing power required from the graphic processing unit, or GPU. It is, of course, possible to display low-resolution images and video on a high-end display, thereby reducing the need for graphic processing power. Initial displays used cathode ray tubes, or CRTs, with a 4:3 screen width-to-height aspect ratio. These displays supported video graphic array, or VGA standards. The earliest VGA standard supported 640 by 480 pixels with a 4-bit 16-color display at 60 Hz. This was superseded by the SVGA standard, supporting 800 by 600 resolution and 4 or 8-bit color. The next iteration, using XGA standards, supported 1024 by 768 pixel displays, 16 or 32-bit colors, and a higher refresh rate. All of these displays used a 4:3 screen width-to-height aspect ratio. With the advent of LED technology, widescreen monitors supporting 16:9 aspect ratios are common. These monitors support high-end resolutions from between 1280 pixels by 720 to 1920 by 1080 for a full HD display. Larger devices use even higher resolutions, such as 3840 by 2160 for 4K or Ultra HD displays, and 7680 by 4320 for 8K displays. Different display and graphic adapters come equipped with different ports that support different connectors and cables. Sometimes the same adapter may have more than one type of connector. Each connector represents an advancement in display technology and brings its own benefits. Let's take a look at each of these in greater detail. High-Definition Multimedia Interface, or HDMI, is the latest and most widely used interface for digital audio and video for televisions, Blu-ray players, computers, and other consumer electronics. Beyond just data transfers, HDMI also provides remote control or CEC support and digital content protection or HDCP. The HDMI connector has a proprietary 19-pin connector in 3 sizes: HDMI 2.1 for regular connections, HDMI Mini for portable electronics such as DVD players, and the micro HDMI for GoPro action cameras, smartphones, and so on. The newer versions of HDMI offer greater bandwidth and can therefore support higher quality resolutions up to 8K. Developed by the Video Electronics Standards Association, or VESA, DisplayPort is designed to complement HDMI and offer a royalty-free alternative. It improves upon the DVI interface and is the first to use packetized data transmission. This allows DisplayPort to transmit higher bandwidths over fewer pins, thereby resulting in almost lossless data transmission. The DisplayPort connector has 20 pins, where 12 are for the main link, 3 pins for the auxiliary channel, 1 for the hot plug detection, 2 for power, and 2 additional ground pins. It can support 7 different transmission modes for progressively increasing bandwidth. Intel and Apple developed the Thunderbolt interface, and this interface remains popular on Apple computers. This versatile cable type functions both as a display and as a peripheral interface. The initial version of Thunderbolt used the Mini DP interface. Thunderbolt version 3 and the current Thunderbolt version 4 both use a USB-C interface. However, it is important to know that a Thunderbolt device plugged into a standard USB-C interface does not support Thunderbolt features, and a USB-C cable plugged into a Thunderbolt interface does not support Thunderbolt features. Developed as an industry standard for digital video content transmission, DVI connects a video source to a display. It transmits uncompressed digital video and can support both analog and digital devices in various formats. The DVI-I interface supports integrated digital and analog equipment on the same connector, while DVI-A supports only analog equipment and DVI-D supports only digital equipment. The digital connectors come in single and dual link formats, where the dual link provides higher bandwidth for resolutions higher than HD TV or 1920 by 1200. This interface was very popular but has since been replaced by HDMI and Thunderbolt or DisplayPort interfaces. One of the earliest interfaces, the VGA, was developed for analog video transmission. Considering that most of the modern graphic devices handle digital content, the VGA is now considered legacy, although some PCs continue to support it. The VGA has a distinctive 15-pin array distributed into 3 rows. The connector can be secured to the port using screws. There are several other connectors used commonly that are worth mentioning here. Apple provides a free license for the Mini DisplayPort, and it can support up to 4K resolutions, so users can connect their computers to HD TVs starting from the 2010 version. Many popular laptop models ship with the Mini DisplayPort interface. Some displays use USB to connect. Universally, cameras use USB ports to connect to computers. Some display monitors also use USB Type-A connectors. And some older televisions, VCRs, and computer monitors use S cables to connect using the S video port. Component RGB is used to process analog video signals. These interfaces typically split video into 3 signals, and usually have 1 or more additional cables for transmitting the audio signal. In this video, you learned that computers need a display unit connected to a screen in order to display graphics and video. Quality of display is based on resolution, bit depth, and refresh rates. and higher quality display requires high-end specialized adapters. The current display systems use 16:9 aspect ratio with LED displays, while older models use CRT displays featuring a 4:3 aspect ratio. And there are different graphic connectors available, and each has its own features.